All right, I kind of spoiled it a little bit here, but we're going to talk about holes here. So, what's different, right, about the x minus 2 than the x plus 2? Because why is there only a vertical asymptote at one of them? Because the other one has a hole. If we look at the graph of, oh, I already got rid of it, but if we look at the graph of that function, you'll find that the function's undefined when x is equal to 2. So when we graph it, we do the sort of thing where we have an asymptote at one place, but when x is 2, we draw an open circle to show a hole. So this last graph actually looked like this, and sometimes Desmos doesn't plot the holes. You have to plot them manually. But if you highlight over it, as we're going to show, then you are going to see that it's still undefined there. So if the denominator has a 0, what does 0 mean for a polynomial? Remember, 0 is the root of a polynomial, right? The root of a polynomial is just when it equals 0. So that makes sense here, because when the bottom polynomial equals 0, we're dividing by 0, which is going to be some kind of problem. It's just a question of which kind of problem is that going to cause for us. So if the denominator has a 0, and this is a little complicated, so bear with me. If the denominator has a 0 and the numerator has the same 0 with at least the same multiplicity, this is important, very important right here. What did multiplicity mean? Multiplicity was how many times that factor happened. So down here, right, multiplicity 1, multiplicity 1, multiplicity 1 on the top, and multiplicity 2s of those factors on the bottom. Then there's going to be a hole. Otherwise, there will be a vertical asymptote. So there's just like a very specific case where there might be a hole. So look over here, right? The denominator had a 0 at x equals 2. But the numerator also had a 0 at x equals 2. And their multiplicities were the same. They both had multiplicity 1. So if it's the same multiplicity or bigger on the top, then there's going to be a hole. So they were the same multiplicity in that case, so there was a hole. So let's practice this. Find the vertical asymptotes and holes, if there are any, of the function below, doing it by hand. So we look at the zeros of the denominator, okay? So there's going to be something at x equals 1. There's going to be something at x equals negative 5, because that's where the denominator is 0. It's the zeros, the roots of that polynomial in the bottom. It's a 4th degree polynomial in the bottom. So we just have to say, okay, well, are these any of these holes? Otherwise, they're asymptotes, vertical asymptotes. So does the numerator have the same 0 with at least the same multiplicity? So x equals 1. There's no 0 of x equals 1 here, so we know this is an asymptote for sure. The other one's the more confusing one. Because notice they do have the same factor. They have the same 0 here of x equals negative 5. So it's a hole if the multiplicity on the top is at least the multiplicity on the bottom. Well, this is multiplicity 1. That was multiplicity 2. So this is not satisfied here. It's only a hole if the top has the same or bigger multiplicity. If the bottom has a bigger multiplicity, then it's a vertical asymptote. So actually, both of these are going to be asymptotes right here. We should have 2 vertical asymptotes. Let's check. X minus 2, x plus 5, x plus 7. Divided by x minus 1. Or is it plus 1? I don't remember. X minus 1 squared, x plus 5 squared. Oh, you can see we do have those 2 vertical asymptotes, right? At x equals 1 and at x equals negative 5. You can see both vertical asymptotes. So this one didn't actually have any holes. But notice If we made this factor on the top have multiplicity 2, now the multiplicity on the top and the bottom are the same. And now, right here, when x is equal to -5, we do have a hole here. When x is equal to -5, we get 0 over 0, undefined. And if we had a higher multiplicity on the top, we'd have the same idea. Oops, I got very concerned there, but I typed it in wrong. Yeah, higher multiplicity on the top, you can see a hole here as well. All right. Let me know if you have any questions, and hopefully this helps with multiplicities, holes, polynomial stuff, vertical asymptotes. Lots of good review in this video. Have a good one.